Good day, my name is Dr. Martin Huber. I am the head of good weighing practice at Mettler Toledo. On June 3rd, 2013, the United States Pharmacopoeia has published a second supplement to the USP 36 National Formulary 31. This video informs you about the relevant changes in the general chapters about weighing, namely USP General Chapters 41 and 1251, which will be official on December 1st, 2013. I'm going to show you the implications of these new chapters for the quality management of balances in 3 parts. How to test the weighing equipment, how often to test it, and how to avoid weighing errors. Probably you're already acquainted with the repeatability test of the old General Chapter 41 weights and balances. Here comes the new chapter with a few small changes.
Repeatability is satisfactory if 2 times the standard deviation of the weighted value divided by the nominal value of the weight used does not exceed 0.10%.
In the new USP 41, first, the expansion factor goes down from 3 to 2. Second, the weighing tolerance changes from 0.1% to 0.10%, meaning a deliberalization of rounding. These 2 changes reflect current metrology practices and virtually compensate each other, so in most cases the minimum weight will remain unchanged. This change was pretty straightforward. Here comes something new: a lower limit for the repeatability test.
If the standard deviation obtained is smaller than 0.41d, where d is the scale interval, replace this standard deviation with 0.41d.
So in case the standard deviation is 0 or just very small, the readability of the balance is not high enough to detect deviations. Therefore, the dominant uncertainty of such a balance is not the repeatability error, but the rounding error, which amounts to 0.41d. So much for repeatability testing. USP 41 now also requires testing for accuracy.
When substances must be accurately weighed, the weighing should be performed using a calibrated balance that meets the requirements defined for repeatability and accuracy.
What's the difference between the two? Repeatability assesses the random error of measurements, or more scientifically speaking, the closeness of agreement between values obtained by replicate measurements on the same object. Accuracy, on the other hand, assesses systematic deviations, or in other words, the trueness of measurements, how close they are to the true value. To weigh reliably, both repeatability and accuracy must meet the defined tolerance of 0.10%. So what test weight should be used for accuracy testing?
A test weight is suitable if it has a mass between 5% and 100% of the balance's capacity.
Note that the current widespread practice of accuracy testing with small weights at the working point is not allowed anymore. At this lower end of measurement range, repeatability is the dominant error and dwarfs the corresponding accuracy error. Hence, for reliable testing of accuracy, a weight between 5 and 100% of the capacity must be used. So we have looked at what types of tests should be performed, namely repeatability and accuracy. USP General Chapter 41 does not dictate how often tests should be performed. This information is provided in the new USP 1251, which, by the way, is not a mandatory chapter, just a helpful recommendation.
The balance check is performed at appropriate intervals, based on applicable standard operating procedures. The frequency of the balance check depends on the risk of the application and the required weighing tolerance.
Note that the new regulation does not mention a daily check anymore, as it was the case in the old Chapter 1251. Reflecting current good manufacturing practices, the new USP regulation now recommends a risk-based approach to determine appropriate frequencies of testing. 2 factors influence the test frequencies. First, the risk of the application. For example, let's classify the impact of potentially inaccurate weighing results into low, medium and high. with low having none or little consequences on product quality or costs, and high meaning that a drug could be ineffective or toxic. The second axis is the required weighing tolerance. If the application is subject to the requirements of USP 41, the weighing tolerance is preset to 0.10%, as we have learned before. For applications outside USP 41, however, the weighing tolerance is defined by the process tolerance. Consequently, the higher the risk, the more testing is recommended. Putting this strategy into practice means that daily or weekly testing, for example, would make sense for high-risk applications. For lower risks, however, less frequent test intervals can be implemented, allowing you to reduce unnecessary testing efforts without compromising compliance. The last thing you should know about the new USP weighing chapters is how to avoid weighing errors.
The minimum net sample weight, M-min, of a balance can be expressed by following equation.
We've already seen the Chapter 41 criteria for repeatability. Solving this equation for the mass yields that the minimum weight must be equal or larger than 2000 times S. USP states that the standard deviation is virtually independent of the sample mass at the lower end of the weighing range. Hence, a test weight of a few percent of the balance capacity can also be used to assess repeatability and derive the minimum weight from this formula. Let's make an example. The standard deviation was measured as 7 microgram, so the minimum weight equals 14 milligram. Establishing the minimum weight of a balance is a simple and effective way to avoid weighing errors. You may think of the minimum weight as the accuracy limit of a balance. As long as you weigh above this limit, measurements are sufficiently accurate. It is important to note that USP now also gives recommendations how to establish the minimum weight for applications outside of USP 41.
If not subject to the requirements of General Chapter 41, the minimum weight value may vary depending on the required weighing tolerance and the specific use of the balance.
This provides useful guidance to ensure accurate measurements of weighing equipment in other parts of the pharmaceutical process chain as well, guaranteeing consistently good product quality.
The minimum weight applies to the sample weight, not to the tare or gross weight.
A common misconception is that if the tare vessel is larger than the minimum weight, the weighing process is in compliance. It is now clearly stated that the net sample weight must be considered and not the gross weight. USP 1251 provides practical recommendations for the qualification and operation of balances. Among others, it describes several environmental factors that can influence the performance of a balance. For example, air currents, temperature variations, vibrations, electrostatics, and many more.
Because of changing environmental conditions, different operators, and other factors that can influence the repeatability of the balance while in use, when possible, weighings should be made at larger values than the minimum weight.
It is therefore recommended to use a safety factor, which ensures that the smallest net weight is sufficiently larger than the minimum weight determined at a particular time by a particular person. The revised USP weighing chapters 41 and 1251 provide valuable new information to improve the quality management of balances. On December 1st, 2013, they will be official. We help you achieve compliance with the new USP chapters. Choose the fast lane for boarding with the weighing experts from Toledo.